All right, so let me just make sure that the recording is up and running, and then we can slowly get started. Right, there we go. And let's hit the recording on Google Meet so we can push this out to our students that cannot be here at the moment. Oh, I forgot to bring some water. All right, people, welcome. Today is the day where I will be torturing you with the introduction to the Ruby programming language. The talk is titled Get to Know Ruby. Some of you might have already heard this once because we do have a recording of this talk at our in our course documentation. But nonetheless, I would love to deliver this directly to you and take your questions, should there be any, once I'm done. Or if you were totally blown away and don't have any questions, then I will be worried. No, I'm kidding. It is what it is. So get to know Ruby. This is the title of today's talk, and subtitled A Path to Programmer Happiness. And isn't that something? Now imagine if we could be happy while we code at all times. Wouldn't that be great? Unfortunately, well, unfortunately, I don't know, but programming is about solving problems, and it's all a mental game. How do you approach problem solving? Now, uh, the thing about Ruby, and that is what got me hooked on this programming language rather than Python, actually, is that approach, that the Ruby programming language is written so that, or created so that people can actually enjoy coding and programming and not just do their job. But more on that in just a second. Let's get after it, folks. Let's see if we can get any smarter today. The learning objectives for today is to learn a little bit more about the philosophy of the Ruby programming language, or philosophy behind that language. But then when we leave the Zen thing out, that and move past that, we're gonna dive into classes and objects, and we're gonna talk about inheritance, and we're gonna talk about modules, and then a little bit about calling methods. Methods are in Ruby what functions are in JavaScript, just so we know that we use that a little bit interchangeably. And we want to try to get comfortable with IRB, which is the interactive Ruby shell, and I will show you that. And if you can, then tag along as much as possible. This is not a session for code alongs per se, because I have a lot of ground to cover, so I won't be able to give you so much support. But most of the examples that I will be showing you are pretty straightforward. They are not that super heavy, so you might actually be able to tag along on most of the things that I am doing. So don't be shy to open up your terminal and code along as much as you can. All right, so let's get started. Let's say hello to Ruby. Now, Yukihiro Matsumoto is the creator of Ruby programming language. We refer to him as Mats. And he was, there's a quote from him here saying that Ruby is designed to make programmers happy. And that really resonated well with me after coming from lower level languages like, C and C# and Java, where I was everything but happy while I was coding in those languages. And that got me curious, and then I started to learn Ruby uh, for myself, and then consequently I started to use that in teaching, because Ruby um, is actually a language that makes programmers happy, and happy people tend to be more interested in what they're doing, and therefore if we put this into the context of education, that's actually a very, very good thing, because happy people tend to learn better, and make better progress. Now, if we think about these small examples that we have on the screen, one of them is written in Ruby and the other one is written in Java. Not JavaScript by any chance, but Java, right? And so if you take a look at the one written in Ruby, it's one line, and it says 5 times print yo. If you look past the dot and the curly brackets, you can almost make out what it's supposed to do, even though you're not a good programmer, right? And if you look at the one written in Java, first of all, more lines of code. Again, this is perhaps not the only way you can do this in the Java programming language, but what I'm trying to say is that this is far more complicated than the Ruby example.
Sorry to interrupt, Thomas. Are you sharing your screen right now?
Am I not? Can't you see me?
No,
No, I can't see any lines of code. I'm going.
Oh
me
gosh,
neither. I was
sorry
like,
guys.
oh,
Well, that's
where
a
do I
bummer.
have?
Thank you for speaking out now. That's
It's all right.
the system.
I
Yeah,
was
I
checking
got you.
Google if I'd done something wrong.
Yeah, no. It's okay. So now you should see it in a second. Hold on, perhaps not yet. Are you seeing something on the screen now?
An OBS symbol.
Okay, hold on a second. I will just fix that in. Right. Right. And now you see something, right?
There we go. Yeah.
Yes. Thank you.
Yes.
Thank
No worries.
you. Sorry about that. That was a big mistake. I'm still getting used to all of this stuff. We are trying out a different way to record these things, and ask David. He knows how much I struggle with this. Anyway, now that you see me, you see these slides. I actually had some more slides, so here we go. These are all the slides that I actually covered before before Luke actually said something. Good on you. Anyways, so the first example is written in Ruby. The second example is written in Java. Now, as beginners, which one would you prefer to work with, David?
First one.
Okay, and Luke?
Yeah, I mean, the first one's got less stuff.
Less stuff, right? And less stuff is good. Would you agree
Second
with
one
that,
is
Christian?
near JavaScript.
Yeah.
Yeah.
It looks.
Yeah.
The first one looks a little bit more easy in the
Yes.
beginning, man.
Yes. And that's exactly my point. That's the point I tried to make it come across, even though I wasn't showing you the slide. I'm sorry about that. Now, if we take a look at another example, like this one, and if you look at the code example here, we say toast, cheese, wine, wrapped in those hard brackets, and then we say dot each do, and then there are those vertical lines that are called pipes, and between them you have a name saying food, which will be a variable, and then inside of the block, which is everything between the do end, you have a command saying print food capitalized. Now this one is less readable than the first example, of course, because it is, after all, a programming language, and it's less sentence-like. But if you think about it, once you know a little bit of Ruby or any other language for that matter, with a little bit of imagination, you can still understand what's going to happen. And if we translate this human language, you could say that with the words toast, cheese, and wine, take each of them and print it capitalized on screen, and that is, in my opinion, pretty readable and a good way to code. Easy to learn, easy to understand, easy to spot any bugs in, and so on. Now, for me, the purpose of life is partly to have joy, programmers often feel joy when they can concentrate on the creative side of programming. So Ruby is designed to make programmers happy. That is the creator of Mats, the creator of the Ruby language. And one thing that I really like to emphasize here is this statement where Mats says that programmers often feel joy when they can concentrate on the creative side of programming. Now, for many people, programming is something that is pretty hardcore. They think that it's all about technology and all about bits and bytes and heavy syntax and so on. For me personally, and this is something that I really would like to convey to you and make you feel, programming is a very creative endeavor. We create stuff out of thin air, out of an idea. We can make things happen on the screen or on any device that we are working on for the time being. I come from a family where both my parents were artists, and to the despair, I never chose that profession. My father said that I had talent, but I was too lazy to learn the techniques that would make me able to paint. He was a painter. Um, but later in life, I discovered programming, and that got me hooked. And I sincerely feel that I can be creative and do fantastic things using technology. And for that matter, this approach that Mats is talking about, like if I can choose a language or a framework or a development environment that allows me to focus less on configuration and on tweaking things, but more on the creative part, that is the better for me, right? And I prefer to choose those actually. So there is a link here to a very interesting interview with Mats, and I would encourage you to read through that interview at some point because it's really inspiring. Some other random quotes about this language is that Ruby will teach you to express your ideas through a computer. You will be writing stories for the machine. Also a fantastic quote. That's why I took it, included that in this presentation. We cannot call it a computer language. It's coder speak. It is the language of our thoughts. That's almost Zen-like. I like that a lot. All right. Let's dive into the language itself. We have to go through some hardcore stuff, some technology, so that we can learn the techniques and about the language good enough so we can actually create with it. So one thing that you might often hear is that everything in Ruby is an object. So let's take a look at that. Now, everything in Ruby is an object, and every object belongs to or is an instance of a class. And this is really important. Take this down as a note. It's an important thing. We will deal with this during this this presentation. Everything is an object, and every object is an instance of a class. Whereas an object per se is the thing that we are currently dealing with, and a class is like a blueprint or a set of instructions how to create that object. We will cover that in depth in this talk. Because being a part of a class gives an object a lot of attributes or methods that can be used to do things with that particular object. And as an object-oriented language, the classes that we use in Ruby holds a lot of power and makes your life easier. And if we look at this on this example, and this might be a little outdated because things has changed since we created the screenshot, we have the number 47, right? And that's the first line, 47. By the way, I would like to ask you guys a question. Do you know the difference between data and information, by any chance? Any of you? Okay, so let me ask this. What is 47?
It's a number.
It is a number.
Yeah.
Does it represent anything?
No, I don't think so.
Well, that's
Not in this
exactly.
situation.
Exactly, not in this situation. Now, so let me tell you this. I have a son, Oliver. He's a huge guy, 2 meters tall, and he has enormous feet. And I think he, when I was writing this presentation, he was a little younger, and so back then he had shoe size of 47 European standard, right? And by then I was 47 years old. So 47 could represent his shoe size, but it could also represent my age. And here's my thing. Here's the point I want to make. Data is just 47 in this case, whereas information is data put into a context, right? So when we talk about my age and we use 47, then this number becomes information. How old are you? 47. 47 becomes information. But if you just randomly say 47 to people, they will not understand what you're talking about because it is not put in a context. Does that make sense?
Yeah.
Right. So in this situation, look, as you were saying, 47 doesn't mean anything else but a random number. All right, so that's the first line. Now, on the second line, I'm asking a question. I say 47.nil question mark, and the answer is false. Of course it is false, because 47 is not nil. It could be nil, but it isn't, right? So we get false. And false is a specific data type. It's called a Boolean. A Boolean can only be two things, true or false. In this case, it is not true, so it is false. So let's say that we ask our language if 47 is a nil class. It is not a nil class. A nil class is a specific class that holds nil in Ruby. It therefore we get false as an answer. However, if we ask Ruby if 47 is a fixed num or an integer, then we get true, because it is actually a fixed num or an integer or even a number nowadays. There is another class, I think, in Ruby nowadays. However, if we ask if 47 is a float, then we get false. And does anyone know the difference between floats and integers in any programming language?
Nope.
Floating point numbers got a decimal point.
Float has decimal points, right? So, and this is important. So integers or numbers are whole numbers, whereas integers are not whole numbers, right? They are numbers, but they have decimals in them. So that's important. And why is that important? Well, because you cannot perform certain calculations between those two data types. Some of them can be done, some other cannot be done. So that is something that you should definitely take down. Difference between floats and integers. Now, in Ruby, there is a fantastic little method on the number class or integer class. So you can say 47.next, and that will return 48, which is quite useful if you want to, count up or do some stuff, basically. So that's really, really nice. And also, and this is something that a lot of students tend to forget, so please take this down as well, that if you call the .methods method on an object, like in this case 47, you will get a list of all the things you can do with that particular object. So 47.methods would return an array, a fairly long array of symbols that would represent or give you the names of all the different methods you can call on 47. And I will show you in just a few moments how you can check this yourself, because this screenshot is taken from the interactive Ruby shell that you have available in your terminals once you have Ruby installed, and most of you have that installed out of the box actually on your computers. Now, as I mentioned, everything is an object. So nil is an object. Nil represents like nothing or nothingness, or I don't know how to describe nil. Actually, it's rather hard. But if we say something like in our Ruby shell, the code example on top, if we say nothing equals nil, and then we invoke the class method on nothing, then we will get back an answer saying that this is a nil class. So dot class is a function, is a method that we can call on that particular object. True or false, already mentioned this. These are booleans, but they are our member of respective class, true class or false class. And I'm only showing you this to make a point that everything is really an object in in Ruby. Now, you can also extend Ruby classes. They are not protected by the language. So if you would like to add your own method or function to the nil object, as I do here, then you can do that, of course, and you can also override anything that is already being created. Not only can you add functionality, but you can also override functionality, and that is important to know about. It could that be dangerous? I would say in certain aspects it could. Is it possible to do in other programming languages? In JavaScript, which is another language that you will learn with us here at Craft Academy, you cannot do that. You cannot override the native prototypes in JavaScript, but in Ruby you can do that. So that's a very significant difference between those two. All right, now you saw all those functions that we can call on any object that we create, or at least on the number 47, as you could clearly see. Now we're gonna start to talk a little bit, or I'm gonna make a segue into inheritance. But before we start to do that, in Ruby there is like an ancestor class to everybody else, and that is called the basic object. And the basic object is an object from which all other objects derive from, and it's a parent class of all the different classes in Ruby. And it's pretty much a blank class with over 100 methods that are already built in. So you can always type basic object in Pascal case in your IRB and call dot methods on it, and then you will see all the methods that are listed. And in this example, I'm also using a chained sequence of method calls. So I say basic object dot methods dot count, and that means that we will first invoke all the methods on the basic object and then count them, and that will return 101. Probably let's do that actually, because I'm curious about it. So if whatever you want to be in your terminal, you just type IRB and then you see this prompt. In my case, it says 2.5.1 because I'm using that version of Ruby. When I was writing this presentation, I was using 2.3.1, as you can see here. So that was a different version of the Ruby language, but the functionality should be probably the same. So if I just say basic object dot methods dot count, then we get 111 nowadays. Okay, so they've added a few methods to that basic object, and these are all the methods that you can invoke on the basic object. But let's move forward. Let's get some basics straight before we get back to inheritance. Let's talk a little bit about classes and objects so that we can get that out of the way. Now, and this is something that is sometimes hard for people to internalize, but classes are blueprints from which all the objects are created, and they hold data and have methods and so on that can modify or interact with that data. And as an example, I usually say that if we take this glass, for instance, there are thousands of these classes. I think this one is bought on an IKEA or somewhere. And at some point, a product designer sat down and wrote and drew a specification of how this glass is supposed to look like. He made a set of blueprints and measurements and what material to use and so on, and then it is being sent off or approved first and then sent off to a factory that manufactures these glasses, and then they are shipped over to the stores and sold to the general public, right? So the blueprint that the designer created is like a class, whereas the glass itself is an object. Does that make sense? Anyone?
Yeah.
Kind of?
Yeah.
Yeah.
Yeah, good. I just wanted
Yeah.
you to hear that. All right. So objects are instances of a class. So we often talk about that we are instantiating objects when we create them, when we give birth to them somehow. So in plain language, you could say that a truck and a car are both objects of a class called vehicle, right? Because these classes could be fairly abstract, actually. An apple and a banana, they could be objects of the class fruit, and then you can, derive from that. And also, since I'm a Star Trek fan, being a nerd as I am, Enterprise and Voyager are instances of a class that could be named Starship, right? So let's take a look at this code snippet that we have on this screen. Oh, sorry. Oh, there we go. We have a class definition, and then we have a method that is called initialize, and we just take one argument, in this case designation, which is like a name of the starship, and we just assign a method to it or a name to it. So let's actually write this up, but I'm gonna exit this and I'm gonna clear my terminal and I'm gonna open up another interactive Ruby shell that is called pry. Pry is actually not part of the programming language. You have to install this package, and you do that by gem install pry. I can show you this later. But let's say, and pry is like IRB on steroids, basically. It's a little better IRB. So let's say that we want to create a class and we want to call it Starship, right? Like this, and then I'm gonna define a method, initialize, and I'm gonna allow this one to take one argument, designation, and then I will just say at designation equals whatever we pass in, meaning designation, like this, and then just say an end to close the initialize method, and then end to close the class definition, like this. And so now I can say Voyager, I can create my new starship. So I can say Voyager equals starship dot new, like this. And I have to open up a parentheses and say as a string, meaning that I need to have a quote mark like this, and I will say Voyager. And here I want to use the proper name, so because that's going to be sat at the name of this thing. So here we have now a Starship object built. So just to refer back to the things that I've showed you before. So if I now take Voyager and call dot class on it, like this, dot class, I will get an answer saying that this is a Starship. Hopefully you guys can see this on screen, right? And if I would say Voyager dot methods, like this, we will still get a lot of methods that we can call on this object, even though my class definition was very, very simple. This is the only thing I wrote. You can still get a lot of output and a lot of things that you can do to this particular starship, which is an object based on the starship class. All right, we're gonna build a few more starships actually in this demo, because we're going to talk a little bit about inheritance. We already touched upon this briefly, but we need to explain this concept in more detail, even though we are just scratching the surface in this talk. Now, in real life, if you as an individual inherit something from someone, it could mean two things. You were probably related to this person in some way, the person from whoever you inherit from. It is in most cases is parent to children or grandparent to grandchildren and so on. And you're either getting a bunch of money when you inherit something, or you have gotten some biological attributes, let's say a nose, your hair color, and so on, right? That is what inheritance is for human beings most often, right? Now, it's very similar in programming, I would argue. Now, the same goes for inheriting from classes. If we take a look at this code, the code that we already the code that we will actually write in just a second, we have two class definitions here. And again, I'm a Trekkie, so I'm going to use Star Trek references. Now, let's say that we do accept that intergalactic travel is possible, and that there are different races in our universe. So in Star Trek, you have the Federation, and you also have Klingons, right? So Federation starships, they have something called ship classes, because that you use to describe a Federation starship, whereas Klingons, they don't really care about ship classes. They actually do, but let's say for the sake of this argument that they don't. But they have something that Federation does not have, and that is cloaking capability, which means that you can render your starship totally invisible. It's actually forbidden by Federation rules, so therefore Federation starships do not have that. Therefore, this information, whether a Federation starship has or has not cloaking capabilities, is irrelevant. We don't want to use that. And since the Klingons don't care about ship classes, we don't use that data to describe a Klingon ship, which means that if we would add these attributes as part of the blueprint to the starship class, then it wouldn't fit the use cases. You understand? It wouldn't be relevant for all instances of this, when we want to describe starships in our fake universe, right? So therefore, what we can do, we can create two new classes, one called Federation Starship and another one called Klingon Warship, and we can allow them to inherit the behavior from the Starship class for all the other things that they have in common. But we create separate classes to describe the attributes that they don't share. And there are plenty of use cases in real life when we move past Star Trek and talk about information systems, when we deal with customers or users or vendors or what have you, right? Where you will have attributes that are common for both instances, but they are not shared by everyone, and therefore you can break out and create different classes for it, and yet you can still inherit from them. So I'm going to create another class here, and I'm going to pull this up a little bit. So I'm going to say class Federation Starship, and now I'm going to use this sign in Ruby. This means that we are going to inherit from the Starship class, right? So I can say Starship like this. And then I'm going to say again def initialize and allow this to take designation as we did before, but also ship class. So next time when we want to create a Federation starship, we need to pass in 2 arguments to this class. All right, so that's the next line of code, and then we will assign an instance variable called ship class to the ship class, and then I will talk to you in just a second what we will do next. So ship class equals ship class. Oh, mistake, spelling mistake. You need to check for that because you don't want to make mistakes here. Right. And then I'm going to say super and pass in designation. And I'm going to tell you on the next slide what super does, because super is a specific thing. Nation. Designation. Now I'm done, and I'm just going to say end to close the initialize class and end to close this this thing. And I will also say class Klingon warship. Was that what we called it? Yes. And I'm going to say starship here, and I'm going to say def initialize, and we're going to say designation, and then cloaking capability. Right, and then we just go say at cloaking capability equals cloaking cap. Oh God, I should have probably chosen better there we go, cloaking capability, cloaking. No spelling mistakes. I don't think so. Perhaps I did. But you know, and
You can't use tab like
not in this
here?
one. No. Not for variable names and and for instance variables. I cannot do that. All right. So now I can say enterprise, or is it called enterprise? That's the way you do it. Right. So now I would say federation. No, really. Federation starship. Why aren't you doing this to me? Why are you doing this to me? Starship dot new, and then we're just going to pass in a name, enterprise, and then as a second argument I will say galaxy, because enterprise is a galaxy starship, class starship, right? So now what oh gosh, I misspelled federation. How embarrassing. What did I say? Federation. That's, oh gosh. There. Oh, and now I'm making another mistake. There we go. Right. So now we have a federation for some dumb reason, but still, you get the point, right? So now, if we call enterprise.class, we can see that it's a federation starship. But here comes the thing. If I now say federation.class.superclass, and then we see that it's a starship, right? So if we ask Ruby, okay, so show me the class of this object, but also show me where does it get his where does it inherit from, so we can access that information by call it superclass on that class, right? Which is a good thing for us. So now we have a now we have both Voyager that we created based on the Starship class, and now we have Enterprise that we created based on the Federation Starship class, and both have designations. And that brings me to another complicated matter. What is super? Now, super is fairly important in all programming in Ruby, because when you call on super in your methods, whether it's in the initialize method or what have you, it searches along the method lookup path, you know, so because each class can have multiple methods on it, and if it doesn't find it, then it looks in the inheritance chain. So, okay, there is no such method inside of me, thinks the class. So, but does my ancestor have a class like this or a method like this? And so in this case, we are just passing in um, this designation to any initialize method that exists in the inheritance class. In this case, the starship, if we're calling that from the Federation starship. So super allows us to write less code and take advantage, less code in our own classes and take advantage of the methods in the mother class that we are invoking. Right. So that brings us to another thing that you probably ask yourself: why did he create an why did he create an initialize method here, here, and also on the starship here? The initialize method is a specific method in all Ruby classes. It is used on all classes. It exists everywhere, whether you have it spelled out or not. Because whenever Ruby creates an object, it looks for this method that is called initialize and executes it. And that is, in a way, a kind of a constructor. It's the first thing that happens when an object is being created. Very much like when a human being is being conceived. You know, after a while, you already know on conception what gender you will have, right? Or and some genetic attributes that the baby will carry. So that is the constructor method of human life. Now in Ruby, whenever an object is created by you based on a specific class, this constructor is being invoked, and it has three responsibilities, of which only one is relevant to you as programmers. The first one, allocate space for the object in the computer's memory, is done automatically. You don't have to worry about that. There are programming languages that require you to allocate memory space. Ruby is not one of those languages. Don't worry about this. However, you should know that it is actually happening. Uh, the the object will be stored in memory somewhere. Then comes the thing that you actually care about, and that is that it assigns instances, the instance that you are about to create, uh, their initial values of the variables, of the attributes, or um, you can also refer to them as, oh, anyway, it's still in my head. Anyway, attributes, let's just call them attributes. So in our case of the starship, we gave them an attribute of a name. We know that we have an attribute of a designation, sorry, and we gave it Enterprise or Voyager, and then we had this ship class, so we gave them this a value of Galaxy when we created the Enterprise ship, right? And then the last thing that the constructor does is to return an instance of that class, meaning that every time, if you think about it, when I do this, right, when I type this, which is the command that I'm issuing in my IRB console, in my pry, then this is being returned to me, right? This is the answer that IRB gives me, or the console gives me. So it returns the object that it just created. It just takes, this is a command that I'm issuing, and then it is being automatically returned to me. So these are the three things that a constructor does, and we care about the one. We need to know about all of them, but we are in control of the one in the middle, because we can control what values those instance variables should get. Now, the initialize method is used for the second job, right? This means that when you call .new on a class, which is a class method and a constructor, and then the initialize method is an instance method used to perform that task, assign instance variables their initial values. And again, I can't stress this enough. Even if you create a very random class with no attributes on it, let's just say class foo, and then end, like this. This is the simplest class definition you're gonna even ever write. I can now say foo.new if I want, and that will return an object that is based on the foo class. But it doesn't do anything, it doesn't hold any data, it has no attributes, but there is still an initialize method called on it, as with every other class, but every other object, sorry, but we don't even have to spell it out. We don't have to include that. All right, let's move on. So these are classes, but then you will encounter something else in Ruby, something that is called modules. So the simplest way to express what a module is basically a collection of data of functionality that cannot be subclassed or instantiated. You cannot call .new on a module, but a module can hold some functionality, some data. So we will continue the Starship examples. And for instance, I can say something like, I can create a module called designation, and I can add a method to that module. It can also contain many methods, and we can say, we can call this method state designation, and we could have that return, I am a member of the, and then a little bit of code, right? And we can then call on that in our code to actually return this string and saying what sort of an object or of a ship this is. So I'm just going to code this hopefully really quickly. So I'm going to say module designation. Oh shoot, sorry. Designation. And then I'm just going to say def state designation. And then I can say I'm a member of the, and then what was it I said? Of the self, right. So I can just say a £, curly brackets, and then end the string. And here I can say state dot class, and right. Actually, we did this right. So we can say split like this, right, and dot first. And here I need to say dash dash like this, and then question mark, right, question mark this, right. So we just do this, right, question mark equals hard brackets a dot z a dash z. There we go. Right. I'm a member of the, right. I think that should be good. And then end of this, right? So now I can add this module to our class definition. So in pry, I can do cd cd starship, and then I say include designation, right, include designation like this, and then cd like this, and now I could say Voyager state designation, not state, it should say self. All right, sorry, cd designation, and then I will just say def state designation, and then I'm just gonna return this, but I'm gonna modify this a little bit because it's not supposed to say state but self. I've been doing too much React programming. Right, I'm a member of the self, right, and then end, and now cd this, and now I can do this split, right. Oh gosh, I'm really sorry. Self class dot name, and not, you see, I forget things. It should say dot name. Nah, name. Is it name? Right, name, of course it is. Right, and cd this, and then Voyager state designation. Right, and now he says I am the member of the star. Right, so this code, what this does is that it takes the class name and splits it based on capital letters. So if we would say enterprise state designation, you could now say I am a member of the federation. So based on the class name, we can now use this first thing, right? So if I would say bird, all right, Klingon ship, for instance, equals Klingon ship, Klingon warship dot new, and we call it bird of prey, and then I just say comma true because you can't cloak this guy, and then I will say Klingon ship dot state designation. I am the member of the Klingon. It doesn't really state designation; it states class, but it's I think you get the point. So we can use this state designation as part of to extract functionality into a specific module, but we can use it on various classes. You can use that to encapsulate some functionality, to include that in the class definition. And then the observant of you would ask, but why would we want to do this in a specific module? Why don't we just add it to the Starship class? And the answer to that is because A, you can, and this is a demo, but B, is that you want perhaps to encapsulate functionality that you can use not only in this context, but also on other classes and classes that you do not inherit from, right? So you can, this is just an example of how you can do what you can do with functionality and reuse that functionality in different parts of your program. Now, there is another way to use, and this is called a mix-in, right? When we include a module into a class, we refer to this as mix-ins. Now, there is another type of module, methods, that are very similar. It's still a module, but you prefix your method name with the keyword self, and that will do something slightly different. Let me type this up. So I'm going to say module execute orders, and then I'm going to say def right self go to warp, and then just pass in an object or ship. Let's call it ship, actually. I can call it whatever I want. Let's go to warp ship, and then I would say ship class initiates warp drive, right? So the only thing is to say again string interpolation, and then we will say ship dot class initiates warp drive, da da da. Right, and then we just say and we say and here, and now I will say execute orders dot, no dot, sorry, parentheses, and then Voyager, and then we would say what? Right, of course not. Go to warp. I forgot that. Go to warp and then Voyager. And now we will say Starship initiates warp drive, right? And if we do the same thing with Enterprise, we will see Federation Starship initiates warp drive. And if we do the same thing with the Klingon ship, you can see Klingon warship initiates warp drive, right? So this is another way. If you look at how I'm using it, I'm not chaining this method, go to warp, into the Voyager or Enterprise. I actually spell out the module name and then the function without the keyword self, because this is now like a module method or a class method, even though this is not a class, bound to that particular module. And then I have to pass in this this object, in this case the starship, as an argument to that particular ship, to that particular method. Sorry. So that's it. And in order to so now I've showed you how you can instantiate new objects based on class definitions or class that you've created yourself. And I showed you how you can encapsulate a little bit of functionality into modules. Of course, these are very trivial examples, but you know, you have to start with something, and Star Trek is interesting enough. So there is another use case, another thing that I need to tell you about, and that is that apart from setting the initial values of the object, when you create the object, you can also modify values later on once that object already has been put into existence, and that is done by getter and setter methods that you need to set up yourself. And let's say that our Federation starship has an attribute of captain, and it would be Thomas, of course, because I would love to be a captain on Enterprise, for instance. So I can set myself as a captain, and I can also ask who is that captain, right? So Enterprise.captain would return Thomas in this case, right? But then I would of course get fired because I'm a lousy starship operator, or definitely a bad captain. So that would have to be updated somehow, right? So we would set somebody else, perhaps Luke, or Luke is a great name. It's a Star Wars name, but anyway. But so perhaps Luke should be a captain. So we have to be able to change that. So if I'm not going to type this up, but if you would like to modify and read the value of captain, then you need something that we refer to as a getter and setter method. You have a setter method to set the value and a getter method to read the value or get the value, right? So in the first column here, we can see an example of how we set the value of captain, and also how we can read that value of in our case captain. But there is a quicker way to do that, and that is by using attribute assessor, attr_assessor, and that would create both the setter and the getter method for us. So for instance, if I would now modify my starship class, and I would say attribute assessor and that would be designation, like this. And now I can just see the app from this. Now I could take, let's say we take a look at Voyager, right? And Voyager has designation Voyager. So now I can say Voyager dot designation, and that would be returned to me, just that name. Before I set this attribute assessor, I was not able to do that. I can also change the name to Voyager 2, for instance, right? Voyager 2. There is no Voyager 2 in the Star Trek universe. And now if I ask for the name, I will see that it's called Voyager 2. And if I just take a look at the entire instance, we can see that designation has been changed, right? So now I'm able to modify that data. So let's say that I cd into Starship again, and our time is up. And I will say attribute assessor, and that would be designation and captain, and we see the out of this. And now I can say enterprise dot captain, and there is no captain, so I'm going to set myself as a captain. So I can say Thomas, sorry, there we go. And now if we take a look at enterprise, we can see that it has a captain, there is a designation, and a ship class Galaxy with 2 A's, which is embarrassing enough. Anyway, so attribute assessor is a very important thing to remember, because it creates a setter and a getter method. And there's also subsequently attribute writer and attribute reader, which are just variants of this convenience method. And the attribute writer will only allow you to set the value but not read it. And attribute reader will only allow you to read the value but not modify it in any way. So that's what that does for us. And finally, if we call some methods, now you've seen me call methods using the dot notation along the way, right? That's the most convenient and the most common name to invoke methods on Ruby objects. Now, if I would like to, then I can use other ways to do that. For instance, object, whatever that is, and then send, and then the method name as a symbol. So if I would now say enterprise dot send, and then as in parentheses captain, that would also return Thomas. So that this is the same thing as this. Oh, sorry, as this, right? It does exactly the same thing. And then there is a third way where you say object dot method, and then the method name as a symbol, and then dot call on that. And so I'm going to do that as well. So enterprise dot method, and then method captain, and then I would just say dot call on that. Enterprise method captain call, and that returns the same thing. So these are the 3 ways to invoke methods. And why am I telling you this at this stage? Because this will come into play at some point during your journey with Ruby. Then you want to call methods slightly differently than just the dot notation. Even though the dot notation is the most common one, you might end up using other ways to do that later on. And then there is another funny way to invoke methods, and that is using the eval function. So you can basically type anything like a string and then try to evaluate this as code. So if I would now say, for instance, something like string equals string equals, and then enterprise captain, right? So if I just call what is string, that will be this, right? So now I can say eval string, and that would actually be executed as code, uh, given that there is actually a valid, some valid code stored in that particular string. Because if it's not, that would render an error. So if I would say, dot something wrong, enterprise dot or dash instead of, no, let's say dot, and I try to evaluate this, we will get an undefined method. We try to evaluate this as code, but it doesn't work because it's not valid code, basically. So this could be very useful. And the reason again why I'm showing you all of this is because in Ruby, since this is an interpreted language, you can in principle create methods on the fly, even if those methods do not exist on the class that you are working with. You can add instance variables, you can define constants and so on. And that kind of touches upon topics like functional programming, which is of course a little bit above your pay grade at this point, but non independently of that, it could be worth knowing about. However, this eval thing, even though it's very convenient, it might be very dangerous, especially in the context of web applications, because if you are not careful, then you can expose yourself to some malicious behavior from bad, people like hackers, if you would enable that for, let's say, values that are sent into your application through forms and stuff like that. So you have to be very careful with that. Anyway, that does it for me. There was a lot of Star Trek references, I know. Hopefully you guys are willing and willing to and interested enough to actually try out some of these trivial and nonsense examples, because if you think about it, they do actually prove a point. And that you will enjoy Ruby as a programming language, and that you will have joy using it and writing software in it. I've heard this before, that Ruby could be compared to Texas Hold'em. It takes 5 minutes to learn and a lifetime to master. And I would say that with this demonstration and with your own ability to actually try things out in your console, or by writing some Ruby software, Ruby programs, you will at least begin your journey to become masters of the language itself. So that's what I had in store for you today, guys. Been a lot of talking. Christer, did I lose you someplace, or did you follow along? Did you find this interesting, and did you
Yeah,
learn something?
yeah, I followed along, but I had a bad connection,
Or
so
was
it
it?
got. Yeah, I had. Maybe it's my internet, so it was kind of blurry.
Okay.
I didn't really see everything you wrote,
Okay. Then
but I can watch it again.
you will definitely be given a chance to watch the recording of this. Absolutely.
Yeah,
David?
and
Yeah, go ahead, Christer. Go ahead.
I'm not really there yet in my course, so I probably have to watch it again when I get there.
Absolutely. Absolutely.
Yeah.
David, did you learn anything today?
Yes, a lot. I mean, this is a new language for me, and it's quite interesting, and I think it's a bit complicated. It's
Oh,
not
it's
that
not.
easy that you tell me.
It's
Yeah.
not. It's not. It's easier, my friend. It's easier than the stuff you've done before.
Okay. Then I need more. I mean, I have to watch the video again and do step by step what you did. So hopefully, I will get along with it. I mean, I will
Absolutely.
get along with it, of course. Yeah.
Trust me. Trust me. It's just the first exposure to this that might be a bit complicated, right? But object classes, modules, methods, pretty simple concepts, to be honest. And you will get into that. No problems. Really, trust me.
Thank you.
Luke, did you pick up anything interesting today, or
Yeah, I mean, I've no experience with Ruby whatsoever, so it's a lot to take in. I will be downloading it on my PC now afterwards myself to try through. But again, it's through Windows, so I have to
That
try
should
it on
work.
there.
Ruby should
Yeah,
work on
Ruby works on
should,
Windows.
yeah,
Okay, great.
yeah, absolutely. No
Perfect.
problems.
So
There's some
I'll be
specific installers, right?
yeah.
Is again, I hope I didn't offend you with the Star Wars reference, Luke.
No. Well, I'm 30 now. I've heard it quite a few times in that time.
I'm not original. I'm a Star Trek fan. You know, I do watch Star Wars if I have to. I have a 7-year-old that loves Star Wars.
I love Star Trek as well, so I was
That's
going
there
along
you
with
go,
everything
brother.
you were saying.
Live long and prosper. You know.
Exactly.
No, so that's good. That's good. Right, and guys, try to look past the Star Trek references. Build a few starships, of course, you know, to follow along with this uh, with my examples. It's not a bad thing to do that, because you know we do cover inheritance, we do cover class definitions, and we do extract some functionality to modules, and all of that will come into play whether you work with Ruby in your career or if you work with any other object-oriented language, and even in JavaScript, because that becomes more and more fully featured programming language. These are the fundamentals. Practice them as much as you can during the preparatory course. That is really, really good for you. And and then just play around, have fun. You know, if you don't like Star Trek, find something else to think about and create some software about. So you know, what sort of class can I do here? How can I encapsulate the information that we are covering about? Let's say if you're into rock and roll, right? A band, a song, you know, a concert could be a class, or you know, a concert is an instance of a class because there is always some attributes in a concert. There is a band, there's a capacity, there's a venue, and the date, for instance, when that concert's going to happen, and so on, right? So you can find your everyday. You just look around you. You can find everyday objects or events that you can describe in code somehow, and think about the common denominators about, let's say, glasses versus cups versus other type of containers, right? And abstract away from the object itself, right? If you, let's say you take a glass, a cup, and a bucket, well, I would say that's a container class, and then you can subclass that into other things, for instance, right? And just play around with this in your thoughts. How can you describe events and objects around that surround you, and that would be a good practice for you. Master the, not master this, but understand these kind of things, because when we move on to build web applications, these kind of fundamental knowledge will come into play and help you a lot in your progression. But anyway, guys, this does it for me. I will be sending out this recording. It's a fantastic sleeping pill. Just put it on your iPhone, plug in some earphones, and you will fall asleep instantly tonight. That's all from me. Thank you.
Perfect. Thank you.
Thank you.
Thank
Bye bye.
you.
Bye
Bye
bye.
bye.
Bye-bye, guys. And also, oh well, go on. Off you go, kids. And to everyone that is listening on stream, on Twitch, thank you very much for watching. I will be back with another stream at some other day. And this time around, I didn't play any proprietary music, which was a good thing, because otherwise uh, the Twitch engine will stop me from talking. And